Hi, I'm Felix Kemo. This is a PPT presentation on the Python basics for data science. So from this, we'll be looking into most of the basic Python programming as it concerns data science. So we'll be moving forward. So, introduction. Data science is a field of study which uses the functionalities of different programming tools in achieving its scopes. The functionalities of these programming languages helps in performing different tasks in data science. As we all know, data science is a field that mix of data. Data science uses the functionalities of many tools, many programming languages in achieving most of its functionalities. And most of these programming languages are Python, Java, JavaScript, Power BI, W, MATLAB, SQL, R, and a lot more. But for the sake and scope of this project, we'll be focusing on the Python basics in data science. Now, why Python for data science? Data science, being a discipline that deals with data and find actionable insights from it, requires a programming language which will manipulate the steps needed for its implementation. This involves a programming language which has capable libraries which are suitable to manipulate data science problems. We have many programming languages available which can also try to be used for data science. But Python is one of the mostly unpopular used programming language which statisticians and data scientists make use of to perform data science projects. Why data science uses Python? Python is easy to learn and understand since it has a simple syntax. So if you are someone that is coming from Java or JavaScript background, you will come to see that when you try to approach Python, most of the syntax of Python seems to be very simple compared to that of Java or to that of C++ or JavaScript. Python is scalable and flexible. In data science, because of the voluminous nature of data, when you try to handle big data, you notice that when you make use of Python to handle big data in data science, Python is able to handle this big data and it won't be slow. And the flexibility part of it, that you can also use Python at the same time collect data. You can also use Python to visualize plots, make graphs, and you can also use the same Python to make some machine learning models. So the versatility of this Python try to make it to be scalable and flexible. Python has a vast collection of libraries for numerical, computational, and data manipulation. So Python makes use of libraries like Pandas, NumPy, Matplotlib, Seaborn, SciPy, Scikit-learn. A lot of these libraries are most of the libraries that Python makes use of in tackling data science problems, which help in ensuring that there are good project analysis when it comes to data science. Most of the programming languages does not really have most of these flexible and voluminous libraries. So these libraries helps to make Python a good use for data science. Python provides graphical data visualization to build plots. If you come to remember, we can use Power BI, W to make some visualizations in data science. But if you are using Python, Python can be used for both data collection, data cleaning, and at the same time you can use the Python to make your visualizations. So actually what Python is doing here, Python has a library which called matplotlib and seaborn. So this matplotlib and seaborn is being used to be able to make visualizations on the data that have been analyzed and cleaned. So this matplotlib and seaborn tends to act like it tends to play the role of Power BI and Tableau. So instead of going to make use of Power BI and Tableau, you just have to import this matplotlib and seaborn libraries from your Python environment, and you run some little set of code and you make any visualizations which you want to. Python has broad community support to help solve many kinds of queries. So one of the better use, or one of the reasons why Python is being used for data science, is that the popularity of Python has made it very common that if you go to most of the Python sites or most of the Python apps, like go to Kaggle, go to or GitHub, you see a lot of Python programmers who are ever there and always ready to help in case of any problem. So this community support really helps in making use of Python for data science. Now let's go into Python proper, where we are going to learn the Python syntax. From here we are going to progress to learn most of the terminologies and concepts about Python. So for now, we are learning Python syntax. The Python syntax defines a set of rules that are used to create a Python program. The Python programming language syntax has many similarities to Perl, C, and Java programming languages. However, there are some definite differences between the languages. Among these Python syntax are Python identifiers, Python naming convention for identifiers, Python reserved words, Python lines and indentation, quotations in Python, comments in Python. This Python syntax can simply be a set of rules, a kind of language, or so let's say rules that Python has set to use. These rules are rules that whenever you use them in Python, Python understand. They try to create the language environment for Python. So whenever you use them incorrectly, Python don't understand what you are doing. So let us look into them one by one. Number one, you have Python identifiers. A Python identifier is a name used to identify a variable, function, class, module, or other objects. An identifier starts with a letter A to Z, that's capital A to Z, or small letter a to small letter z. Or it can also start with an underscore or digit ranging from 0 to 9. Python identifiers does not allow punctuation characters such as @ or the $ or percentage sign in between identifiers. It is a case-sensitive programming language. Python is very case sensitive in the sense that if you try to, for example, you are trying to write an identifier and you want to write welcome, capital letter W, and when you are trying to call this back in your program, you mistakenly put it to be small letter W, welcome. Python do not really know what is this again, because this have to be capital W, welcome, as in this case. So Python is so case sensitive that provided you add any syntax that Python did not really recognize, Python will surely prompt an error. Or once you initiate an identifier with a common type of letter and you try to call it, you do not maintain the nature of that same letter, Python will surely prompt an error. So that's what really happened between the Python identifiers. It's a name used to identify a variable. It can be a function, it can be a class, a module in Python. As time goes on, we know what a function is and also that of a class. Let's look at the second Python syntax, which is naming convention for Python identifiers. One of the naming convention for Python identifiers is that Python class names start with an uppercase letter. All other identifiers start with a lowercase letter. So when you're trying to form a class name for Python, you usually start with an uppercase letter, that is a capital letter, and any other letters that follows it must be in lowercase. That's one of the convention for Python identifiers. For those that understand making a class in Python, you understand what I'm saying. Then secondly, starting an identifier with a single leading underscore indicates that the identifier is a private identifier. There are some Python identifiers that usually start with an underscore, and after an underscore some letters follows it. This indicates that such an identifier is a private identifier. Then when you start an identifier with two leading underscores, it indicates a strongly private identifier. Then number 4, if the identifier also ends with two throwing underscores, the identifier is a language defined special name. So the naming convention for Python identifiers makes it possible for Python to be able to be sensitive to most of the inputs that the programmer gives to it. So by this convention, Python already knows what that is expected of you to give to him. So if you are trying to name a class and you start it with a small letter, then invariably Python don't know what you are doing. But when you actually try to create a class and you start it with an uppercase letter followed by small letters, then actually you are following the convention of Python. This is how sensitive Python works. So going to the next Python syntax is Python reserved words. All the Python keywords contain lowercase only. These are reserved words which you cannot use as a constant or a variable or any other identifier names. In Python, there are some reserved words that have been inputted into Python by the programmers, especially those who programmed Python. These reserved words can never be used by a programmer when he or she is trying to write a code. So if I'm trying to write a code now, I cannot use any of these reserved words to be a variable or a kind of an identifier in my program. So these reserved words are always there in Python, which I can always call them into my program, but I can never use them in case of variable or identifier. Example of these Python keywords is def, which is used to define a function. You have your del, you have your fif. Your elif is for conditional statements. Your and, as, assert, break, class, continue, else, except, false, finally, for, from, global. If is one of the conditional statements used for conditional statement. Import usually work when you are trying to import a library. In is lambda, non-local, not, or, pass, raise, return, true, try, while, with, yield. These and many more. There are also many more reserved words out there in Python. So these reserved words can never be used as a variable or any other identifier names. They are there in Python. If you want to use them, you call them, and once you call them, you can use them to run your Python program. But they can never be a variable or an identifier name. So let's look at the next Python syntax, which is Python lines and indentation. Python provides no braces to indicate blocks of code for class and function definitions of flow control. Blocks of code are denoted by line indentation, which is rigidly enforced. The number of spaces in the indentation is variable, but all statements within the block must be indented the same amount. Let's take a good look at this block of code. What's trying to happen here? We have a block of code this is a kind of a conditional statement. It's representing our block of code, just using it for the sake of an example. So if you have if true, print true, else print false. So you can take a good look at it, because we are trying to look at lines and indentation. So you can check that if true, having this colon, so the print true cannot be in the same line and cannot be in the same indentation with the if true, because this is part of if true. So if you run this in PyCharm, once you want to write print true, the program or the PyCharm environment automatically gives you a kind of an indentation here, a space, whereby you will write print true here. Anything that makes this print true to be in line with the if true, then automatically the code will actually prompt an error. So this block of code forms an error, but in Python, all the continuous lines indented with same number of spaces would form a block. Let's look at the next Python syntax, which is quotations in Python. Python accepts single, double, and triple quotes to denote string literals, as long as the same type of quote start and end the string. In Python, when you are trying to write program, we have quotations that are quotes that are being used, and these quotes are mostly used when we are trying to input a string. So we can make use of a single quote, as in this case, or it can be a double quote, or it can be a triple quote. But the rule here is that if you start a string or a set of code with a single quote, then it must also end with a single quote. If you start with a double quote, then it must surely end with a double quote, and also the same applies to triple quote. So Python is very sensitive. When you start with a single quote and end with a double quote, then that will prompt an error. The triple quotes are used to span the string across multiple lines. Now let's take a good example at the following. Word equals to word. So word being an identifier is inputting a string word. You can print word. Now this takes a single quote and it's end with a single quote. So we see the next identifier, the next variable, sentence. Sentence is being inputted into it a string with a double quote. This is a sentence which also ends with a double quote. And you can see the print statement here, print sentence. If you go to the next variable, paragraph, we started with a triple. You have a string starting with a triple quote, which also end with a triple quote. So the quotations in Python are very sensitive to Python, especially when you use them correctly and also when you use them interchangeably. Pythons always follow the rules that is guiding each of these quotations. Let's move to the next Python syntax, which is comments in Python. A comment is a programmer readable explanation or annotation in the Python source code. They are added with the purpose of making the source code easier for humans to understand. In Python, a hash sign that is not inside a string literal begins a comment. So if you are writing a program, programmers always use some kind of statement to explain the program they are writing. And this statement are being started with a hash sign. And this hash sign tries to connote or denote that the statement is a comment in Python. Although these comments, when they are being written, they are not written inside a particular set of code, but rather they are written as a block of code on their own which starts with a hash sign. They helps in explaining the program proper for readers to understand. Now let's look at Python control structures. Python's control structure are fundamental components in Python that enable decision making within a program. Primarily, these structures consist of conditional statements like if, elif, and else, which allow the program to execute specific code blocks based on whether certain conditions are met or not. Python control structures consist of conditional statements. These conditional statements are mostly if, elif, and else. These if, elif, and else are being used in writing conditional statements which in a program tries to determine the possibility of something happening or not. Control structures also work with loops, and as also work with loops, there are always presence of some kind of iteration within the program. So control structures are very important in Python because they helps in the possibility of making certain events happening or not. They control some flow of happenings within the program. So let's look at types of Python control structures. Number one, we have sequential control structures. The default control structure where statements are executed in order. This means that each statement is executed one after another without any conditional check or loops. So if you try to follow a kind of default way of writing our programs, then you see that immediately you write each of your programs by running the print statement on your programs. The Python automatically interprets them line by line, and each of the set of code is interpreted and given the result. This kind of sequential control structure. Then if you go to number two, we have selection control structure. This is used to make decisions and branch, such as with if, elif, and else statement. So in selection control structure, we try to employ the usability of the if conditional statement, elif conditional statement, and else conditional statement to try to condition the activities or the happenings that is going on within our program. So if you are trying to write a program for the possibility of something happening, so we can say that if Tom and Jerry must play, then you can say that print Tom behaves like Jerry. Then if they must not play, then print Tom is Tom. So this is a kind of a way of trying to, like, if this is going to happen, then it must be this. But if it's not going to happen, that's why you make use of elif, that is else. If it's not going to happen, that elif, then it must be this. So in case of economy, if the price is low, then print quantity demanded will be high. Elif, print quantity demanded low. So the if and elif conditional statement tries to condition the opponents within the program. That is the selection control structures. Then the third one, repetition control structures. This is used to loop or repeat a piece of code multiple times. This is where loops comes into our program, where it seems to have some kind of iteration within the program. It is known as repetition control structures. So moving forward, we look at control statements in Python. Control statement in Python guides the flow of execution in a program based on condition. These statements include if, else, elif, loops, for while, and keywords like break, continue, and pairs to manage loop execution. So as I explained earlier, Control statement are simply this statement that is being used to condition the happenings within the program. So may you use of if, else, elif, I've explained that, and also loops. Then also we also have some conditional statement like break, where you are writing a block of code with a particular logic, and when you bring in the break conditional statement, the break tries to like a form of like stopping or cutting the particular block of code that comes before it, and the continue statement tries to continue the block of code that comes after it. So these different control statements are what makes they play a vital role in our program. They try to condition the happenings that are going on within the program. Let's look at the block of code showing control structures. Here I try to write a program about a guessing game. So in this program, I'm trying the logic behind this guessing game is that I'm trying to play with the computer. It's like a game. So I'm trying to play with the computer. I'm going to input a certain number, to the computer based on the certain limits I give to the computer. So the computer is going to predict if the number I give to him is right or not. So for me to be able to do this, I import a library which is random. I import the random library, then I initiated a function. So there guess x. If random number, which is a variable, random.randint, guess, here I define it to be 0. Y guess does not equals to random number. Random number is a number which we are trying to play with. So y guess, the guess number we are trying to look at must be from 0 up. So y guess does not equals to random number. So the guess, I don't expect my guess to be equal to the random number. So y guess does not equals to random number. Guess, I try to make an input here, should be an integer, and as an integer, it should guess a number between 1 and any number which I will input here, which is x. The number can be 20, it can be 10, it can be 50. So the guess should be an integer between 1 to 100, and you should input guess a number between 1 and let me say 10. So here I try to bring in control structure by starting with an if conditional statement. So I said if the guess is less than random number. So if the number I'm guessing is less than the random number which the computer is trying to predict, then print sorry, number is too low. So provided the number I'm guessing is less than the random number that the computer have, then the computer will surely print to me, that's by telling me that sorry, the number you have predicted is too low. Elif, that is if the number I'm guessing is greater than the random number with the computer, then the computer is going to print to me that sorry, the number you have guessed is too high, and it should tell me to guess again. But exceptional of this if and elif conditional statements, assuming I guess the number correctly, then the computer will tell me print. The computer will tell me, yeah, congrats, you guessed the correct number, and the guessing game will now be kind of a success. So this is actually a kind of block of code that tries to explain what control structures are actually talking about. So it's one of those set of codes that we try to learn as our elementary stage in learning Python. So it's a very simple and nice program that we always use to learn more things about Python programming. Well, this, if you look at it very well, my prompt an error because it's not really in PyCharm environment or in a Python environment. But for the sake of explanation, I think this sounds better. So now let's go and check functions in Python. A function is a block of code which only runs when it is called. You can pass data which is known as parameters. So you can pass parameters into a function. In Python, a function is created using the def keyword, that is the def keyword. A function is a block of code which only runs when you call it. So provided you have not called a function cannot run. And this function can be, you can always call it by yourself. So for example, we try to write function here, call a function here, say df my function, and I say print hello, how are you? This def my function is a function I try to call here, which I go down there to print hello statement there. So functions always work when you try to call it, or at times you initiate yourself. Then let's look at types of functions in Python. There are 4 major functions in Python. They are as follows: built-in functions, user-defined functions, recursive functions, and lambda functions. Let's look at them one by one. Built-in functions. Built-in functions are predefined functions in Python that allows using the basic properties of string and numbers in your rules. There are 60 plus built-in functions in Python, and the top 10 examples are ABS, char, dict, files for dictionary, enumerate, float, len, list, odd, range, and set. These built-in functions, they are functions that are already embedded in the Python environment for use. So when Python was programmed by the early programmers of Python, they have already built in these functions into it. Like the float. The float is already an inbuilt function in Python. So it's a function that it can be used as a local identifier or a variable. So this len, list, float, range, or even set, they are already inbuilt functions. You can't use them. You can only call them when you want to make use of them. Then we have user-defined functions. User-defined functions are functions that are defined by the programmer to perform a specific task. So as a programmer, apart from making use of built-in functions, at times the logic of your program demands that you set some kind of user-defined function. You define the functions you want to make use of. And when you define these functions, you can progress with the function and use this to write the kind of code you want based on the logic of the program you are writing. Then we have recursive functions. Recursive functions, Python also accepts function recursion, which means a define can call itself. Recursion is a common mathematical or programming concept. It means a function can call itself. So this is the ability of a function to call itself. So functions that tries to call itself, we refer to them as recursive functions. Then the fourth one is lambda functions. A lambda function is an anonymous function. That is a function defined without a name that can take any number of arguments, but unlike normal functions. So lambda functions is always an anonymous function, always defined, and it's not always at times with a name. So let's go and look deeply into Python libraries, and here we are going to focus more detail into how Python libraries affect data science. So a Python library is a collection of pre-written code modules and functions that developers can readily use in their Python programs to perform specific tasks. It provides usable tools for common operations like data analysis, visualization, machine learning, and web development, thus simplifying the coding process and improving efficiency. Python library, as we all know, are set of codes and modules, in fact functions that developers have already used in their Python programs. These Python libraries are always written and kept there to avoid the programmer in going into more details in programming explicitly to gain a particular or achieve a particular task. So for example, if you are working in data science and you want to do your machine learning, or you want to build some machine learning models, you see that when you are trying to build some models, you have to work with some algorithm, and instead of you going as far as making some explicit programming to build some of this algorithm, you try to import some of these libraries. For example, you import scikit-learn, and scikit-learn as a library have different functionalities which will help you already import the algorithm itself and help you build some of the models you want to build in machine learning. So that is how good Python libraries are, and it's very, very important in programming. So let's look at some of the popular examples of Python libraries. We have NumPy, we have Pandas, we have scikit-learn, matplotlib, scipy, seaborn, random. These are most of the popular, especially in machine learning. Others include TensorFlow, PyTorch, Keras, Scrapy, Turtle, etc. There are still many Python library out there. But for the purpose of this project, we shall be discussing Python libraries necessary for data science. So now let's look at the Python libraries for data science. Number one is Pandas. Pandas is a Python library used for working with data sets. It has functions for analyzing, cleaning, exploring, and manipulating data. Pandas allow us to analyze big data sets and make conclusions on statistical theories. Pandas helps in making the clean data set readable and relevant. So for those of us that are data scientists, when we try to work with data using Python, we import the Pandas library. The Pandas library always helps us to read the data, to clean the data, and also provide some statistical analysis of our data. So for those people that are good in Excel, when you are trying to make some Excel in data analysis, we are using Python, we import Pandas, and Pandas we do most of the work that Excel is doing. So Pandas help us in trying to even present our data from a CSV format into a kind of a tabular format where we can see it as if it's in an Excel format. So Pandas help in dropping mixing values, removing duplicates, tackling null values, and also renaming columns. It also provides statistical analysis of the data, like the maximum and minimum values, the standard deviation, the average, or at times tries to depict the correlation between two or more columns. The name Pandas has a reference to both panel data and Python data analysis, and this Pandas was created by Wes McKinney in 2008. Let's move to the second library, which is NumPy. NumPy is a Python library used with arrays. It also has functions for working in the domain of linear algebra, Fourier transform, and matrices. NumPy aims to provide an array object that is up to 50 times faster than traditional Python list. NumPy in Python is called NdArray. The array object in Python is called NdArray. It provides a lot of supporting functions that make working with NdArray very easy. NumPy as a Python library is written in Python, but most of the part that requires faster computation are written in C or C++. NumPy stands for numerical Python. So NumPy is one of the Python libraries which is very usable in data science because it tries to work with most of the mathematical domains which we have in data science. So NumPy tries to work or is being used to handle most of the linear algebra and Fourier transform we have in data science. And not just in data science, but even in statistics, NumPy can be employed in handling most of the matrices problem. So NumPy is a very active and one of the most common Python library that is being used by data scientists. So moving to the third Python libraries for data science, we have number 3 to be Matplotlib. Matplotlib is a popular data visualization library in Python. It's often used for creating static, interactive, and animated visualizations in Python. Matplotlib allows you to generate plots, histograms, bar charts, scatter plots with just few lines of code. If you can remember, in data science, when we try to collect our data and clean the data, we always try to see the information the data is bringing to us, and that's why those people out there who are not really using Python, by the time they use of the Excel and the SQL in collecting and cleaning the data, they always make use of the Tableau and Power BI to visualize the data. But those using Python, the Python programmers or the data scientists using Python, they don't go as far as employing the functionality of Power BI and Tableau. So you can just import Matplotlib, which is a library in Python, and once you import this Matplotlib, it tries to create plots for you, and these are the same plot that Power BI or Tableau would have created for you. So what Matplotlib tries to do, it tries to allow you to generate plots, histograms, sometimes graphs, bar charts, scatter plots, and this plot gives you the true information of what is really happening with your data. So if you want to install Matplotlib, you use pip install Matplotlib, and that will be installed in your shell. So another Python library for data science is Seaborn. Seaborn is a Python visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. It builds on top Matplotlib and integrates closely with Pandas structure. Seaborn helps you understand and explore data. It provides beautiful default styles and color palette to make statistical plots more attractive. Seaborn is a kind of an advanced Matplotlib library. Seaborn is built on Matplotlib, and Seaborn performs the same functionalities with Matplotlib. So if you truly understand the functionalities of Matplotlib, then you already understand that of Seaborn. The only difference is that Seaborn provides more information, more statistical information, and it also provides more graphics. Seaborn tries to add more beauty or a kind of more color or more information to your plots than Matplotlib. Thank you very much. We have been able to look at how Python programming is affecting data science and the basics on how Python programming is being used in data science. So with the help of all these that we have been able to look at today, you will see that Python programming is very important in data science because the functionalities of most of the libraries in Python programming helps data scientists in making their project run faster. So in all that data scientists do, they try to make use of Python, most especially to help them fasten their processes. And with the availability or the versatility of Python, especially as it comes with its functionalities and its libraries, data scientists always achieve most of their aims, most especially when it comes in machine learning, when they are trying to build models. So by the time they try to build models, you notice that Python already have fast and good models, that libraries that have good algorithm which they can use in their machine learning algorithm, and also at times in artificial intelligence. So Python is one of the programming languages I always recommend for people out there who is going to data science to learn, because with the knowledge of Python, data science always become so meaningful, and you enjoy using Python for data science. Thank you very much.